Okay, in this video we're going to try and make a binomial distribution and have a look at it. So here's the problem we're looking at. A test is given that has 10 questions and you're purely guessing because you didn't study at all. And each question is multiple choice with 5 choices. So your odds of getting a question right are 0.2, and we'll leave these variables so we can change them. And so we're going to see what your probability of getting 0 right is, 1, 2, and so on. We'll find them all. So first I go to fx here. And I'm looking at statistical. So if yours wasn't selected to statistical, you might need to do that. And then choose the binomial distribution. It pulls up this little box which will help us set it up. Number S. Individual terms of binomial distribution probability is the number of successes for S. Okay, so that's what's going to change, 0 through 10. We want to find all these various probabilities. Trials is the number of trials. There are 10 questions on our test. I'm going to put a $sign here because I want to freeze that. I'm going to put a $sign on this A, for I'll need later because I'm going to move the same command over to do cumulative distribution. So I don't want the A changing. I want these to stay, these 0 through 10 in this column here. Probability S, probability of success. That's this 0.2. I'm going to put a $sign in front of the 1 because when I copy the command down, I don't want that 1 changing to 2, 3, and 4, and so on. And cumulative at first will be false. I want to get just the probability of getting that number right. So we got the answer for 1. Now the beauty of Excel compared to your calculator or anything else is, of course, I can copy that command down, and those frozen S's kept these from copying down with me. Let's have a look at our distribution as a plot. So I come up here to the top. I'm going to choose a scatter plot, so it uses those as X and Y data points, and I'm going to plot it with a line. And here, give me a moment to move it into the window. Not cooperating, but here we go. Here's a picture of it. As expected, our expected value is 2. 0.2 times 10. We expect to get around 2 right. And so that's our highest point. And we see the plot. It's kind of looking like a normal, but of course it's clipped off here. Binomials will begin to approximate normals as you get more data. Okay, so that's one plot. Let's pull it out of the way for a moment. Perhaps just delete it. Okay, and now we'll do the cumulative. So to do the cumulative, simply going to copy this command over to here. Okay, so something didn't work. $A2. Let's see. We'll just do it again then, rather than reinvent the wheel here. F of x, binomial distribution, number of trials, number of successes, right here. Number of trials, 10. We freeze the 1 again. Probability S, 0.2. We freeze the 1 so it won't change. And cumulative will be true this time. And of course for that one it's the same. What cumulative is doing is adding the probability of 0 through the number of successes. So 0 through 0 is the same thing. And we pull it on down here. And of course it'll end up at 1. So what this is saying, for example, here at 2, it's probably to get a 0, 1, or 2 right on this test. 67%, 0.67. You will get 0, 1, or 2. 87% you'll get 0, 1, 2, or 3. Actually plot both of these on the same plot if we wanted to. I'm not getting exactly the plot I want here. But nevertheless, hopefully this has been helpful to you. Now, how we could use this. Let's say I asked you a question that said, what is the probability you will score a 5 or a 4 or better on this test? Well, we could use the cumulative because we know your probability of scoring 0 through 3 is 0.87. So 1 minus 0.87 would give you the probability of scoring 4 or better on this test.